Okay, it seems we're live, so hi everyone. My name is Dmitry. Today we are streaming our new weekly episode of our weekly show called ePMP Now. And the topic for this week is quality of service. And quality of service, as you can guess, the name of our show is ePMP Now, so it's quality of service on ePMP. How it works, how you can configure it, and the same as I did before with the VLANs, I want to cover it under 15 minutes. So just a quick overview, and I don't want to make you fall asleep watching me talking about some geek stuff. So quality of service. Quality of service on ePMP consists of two pillars. One of it is prioritization, and another one is rate limiting. So prioritization is used to prioritize certain types of data, like voice over IP, video data, management traffic, and other stuff. And rate limiting is used to limit customers' data and provide them different data plans, for example, 1 megabit per second, 2 megabits per second. Let's go step by step and start with the prioritization. So prioritization, how it works. For different types of data, it works differently. So for unicast, there are no pre-configured automatic rules to prioritize unicast data. So if you want to prioritize certain unicast data like voice over IP or video data or your management VLAN, you have to create manual rules on ePMP, and I will show you how to do it a little bit further. Broadcast and multicast traffic, by default, all the broadcast and multicast is going in the low priority, and the same with unicast. By default, all the traffic is going in low priority, but you can trigger and change this setting. This is how it looks like in the web interface. It looks more or less the same, the prioritization part called traffic priority. It looks the same on the AP and on the subscriber side. And first of all, if you want to change any rules for traffic priority, you have to enable it on the top, traffic priority. Then you can trigger priorities for broadcast and multicast. There are different radio buttons you can choose for broadcast and for multicast. By default, as I told you, everything is going to the low priority. And there are 3 levels of priority. The top one is called voice priority. The next level is called high. And the third level is called low priority. So 3 levels of priority. At the bottom of this page, you can see the rules. This is the manual rules you can use to change the priority for the specific data. You can use any kind of rules based on the IP addresses, MAC addresses, ports, subnets, 802.1p VLAN priority tags, anything you wish, anything you use in your network can be created in those rules. So how those priorities works? As I told you, there are 3 different queues for each subscriber. The voice priority queue, the high priority queue, and the low priority queue. Based on the queue, there is a mechanism called weighted fair queuing. So each of those queues has its own weight, and based on this weight, certain number of packets will be sent from the highest priority queue, then certain number of packets based on the weight from the next priority queue, and then from the lowest priority queue. So this mechanism called weighted fair queuing. What we can do, and what we heard from many customers, if you have your own customer calling you and complaining my multiplayer game doesn't work well for me because of your high latency. So to improve customer satisfaction and to improve the latency, the ping for certain customers, especially for online gamers, if their comrades are dying and their tanks are blown, what you can do? There is a special mechanism called subscriber model priority. And again, there are 3 levels of this priority. By default, all the subscribers has the normal priority. But for specific customers, especially for the gamers, you can set the high priority. For the free customers, if you have any, you can set it to low priority. So they will be served with the lowest priority and they will have the worst experience. So again, if you want to prioritize gamers that are complaining about the latency, you can use this mechanism. The next step is rate limiting. Rate limiting, what it is? If you have a lot of packets, or in my picture, it's a long queue of people trying to get to the museum. What we can do? We can limit amount of packets going, and it is called rate limiting, or in our system it is called MIR, maximum information rate. To do this, you have to create so-called MIR profiles. MIR profiles, they are created on the base station, on the access point. There are 16 MIR profiles you can create. For each of those profiles, you can set up the maximum downlink and uplink rate, and it will be used in scheduling of the packets. So separate uplink, downlink settings available for each MIR profile. It is token bucket, so-called token bucket based mechanism for each station. And this mechanism has radius integration, so you can set up MIR profiles through radius. And if you want to get more information how the radius integration works, I strongly recommend to download our user guide. I know it's a little bit long, about 400 pages, but it has all information needed to get this up and running. If you want to have a shortcut and don't want to read all this information, you can always get to our community forum and ask questions through the community forum, and we will try our best to answer your question, and other customers like you will try to help you. This is how interface for the MIR profiles look like on the access point. So in my example, there are 4 MIR profiles created. The default, basically, it is unlimited. It is 100 megabits per second downlink and 100 megabits uplink. And there are 3 different other profiles created with a low price, mid price, and premium price with different speeds available. So this is the access point configuration. On the subscriber side, all you have to do is assign the MIR profile on the top of the page. So for the low speed, you have, for the low price, low speed, you have to specify the first MIR profile on the top. For the highest speed, you can leave 0 and it will be basically unlimited. So this is MIR profiles. And the last thing I would emphasize and I would like to talk about is voice over IP, because voice over IP in ePMP system is different. So we treat voice different because this kind of data, it requires stable jitter, and it requires the stable latency. So this is the main requirement for the voice over IP. So the voice over IP queue is unique about it. We have lots of tricks to satisfy voice over IP quality. One of them is piggybacking, meaning that subscriber can tell access point to allocate more time for this specific subscriber if there is any voice data coming. So if you have an active call, access point will know that there is a requirement to allocate more time for this AP to get the stable jitter for the voice data. And to get the best quality for the voice over IP, we have advanced test lab in our office to test the voice over IP quality calls. So it was a quick overview of the quality of service features we have in ePMP. And I bet I didn't cover all of the details. And if you have any specific questions how quality of service works, please feel free to ask your questions on our community forum, or just leave your question under on our Facebook page under this video or on the YouTube page, and I would love to answer it. So thank you, and see you next week, the same time on Wednesday. We will be live with our weekly show ePMP Now. Thank you.